Hi students, today I am going to explain spherical mirrors in the chapter Light, Reflection and Refraction in Physics. So what are spherical mirrors? A spherical mirror means a mirror which can be curved. It can be curved inwards or outwards. A spherical mirror whose reflecting surface is curved inwards. If the reflecting surface is curved inwards, if it is inwards it is curved, then it is called a concave mirror. It is called concave. Cave, like cave. The cave which goes inside, like this. When the spherical mirror is curved inside, it is called a concave mirror. And so the schematic representation I showed already here. Then what are convex mirrors? Is a spherical mirrors whose reflecting surface is curved outwards. So when the reflecting surface is curved outwards, it is called convex mirror. X outside, concave inside, cave will be inside, so concave mirror. X is means outside, exit, so outside. So like this you can remember easily. So you may now understand the surface of the spoon. Hi, when we take a spoon, so which is curved inside, this side is concave, and which is bulged outwards, this is convex. So concave mirror, convex mirror. Yes. Okay. Understood what are spherical mirrors, what is concave mirror and what is convex mirror. Next we will see some points we have to remember. So the center of the reflecting surface of a spherical mirror is a point called pole. The center of the reflecting surface is pole. It is represented by P. So it lies on the surface of the mirror. So the pole always lies on the surface of the mirror. The pole is usually represented by letter P. Next is we want to know the reflecting surface of a spherical mirror forms a part of a sphere. So this reflecting surface, it will forms a part of a sphere. So it will form, it is one part of a sphere. So, and the sphere has a center. When we see the sphere, it will have one center, right? So center, this point is called center of curvature of the spherical mirror. So this, the center of the sphere is called center of curvature and it is represented by C. So it is represented by letter C. The center of curvature is not a part of mirror. We can see here it is not a part of a mirror. It is only the center of the curvature. So it will be, it lies outside its reflecting surface. So it is outside the reflecting surface. It is not on the reflecting surface. It lies outside to the reflecting surface. The center of a curvature of a concave mirror lies in front of it. And however, it lies behind the mirror in case of convex mirror. In case of so we can see here the center of the curvature. So the center of the curvature of a concave mirror lies in front of it. It is present in the front of it. And in case of convex mirror, it is present this side, means it is present behind the mirror in the case of convex mirror. Next we will discuss about R. What is R? Radius of curvature of the mirror. So the radius of a sphere of which the reflecting surface of a spherical mirror forms a part is called radius of curvature. So when we see here, it forms a circle and the radius of the curvature. So radius of the circle is nothing but radius of the curvature. Means the distance from P to C is R. Then next we are discussing about what is principal axis. What is principal axis? If we see an imaginary line passing from the center of the curvature and also the pole is called, this line is called principal axis. So remember, the principal axis is normal to the mirror of its pole. So normal means it will be in the 90 degrees from the pole. So this is pole and this is going in the normal to the pole. So the imaginary line drawn, a imaginary line passing through the center of the curvature and also pole is called principal axis. Then see, we can see in both the cases. So the principal axis. So next, see, when we see, hold a concave mirror in your hand and direct it to its reflecting surface towards the sun. When we hold a concave mirror and when we direct it to the reflecting surface to the sun, direct the light reflecting by the mirror on a sheet of paper held close to the mirror, or we just direct the light by the mirror to a sheet of paper. So move the sheet of paper back and forth so that a bright sharp spot of light appears. After some time, what happens? The paper will burn and it will produce smoke. Why it will catch fire? Because the light from the sun is converged at a point. What do you mean by converge? Means the light will all meet at a point, at a sharp bright spot by the mirror. In fact, this spot of light is the image of the sun on the sheet of the paper. So the image of the sun is formed on the sheet of the paper. That is called focus of the concave mirror. See here. So when the rays are falling on the reflecting surface of a concave mirror, so it will reflect back and all will meet at a point. That is called focus of the concave mirror. So because of this focus, more concentration of light, the heat is produced. So the distance of this image from the position of the mirror gives focal length. Means the distance from F to the mirror P. F to P is nothing but focal length. So a number of rays passing parallel to the parallel principal axis are falling on the concave mirror. So many rays are passing parallel to the principal axis are falling on concave mirror. See the reflected rays. So all they are meeting or intersecting at a point on the principal axis of the mirror. That point is called principal focus, or we can say just focus also. Similarly, rays parallel to the principal axis reflected by convex mirror. I told about concave mirror, they are all meeting at a point called focus. So what happens in the case of convex mirror? The reflected rays appear to come from a point on the principal axis. Here they are meeting at a point. That's why concave mirror is called converging mirror. So here it looks like it is splitting up. So it is diverging. So this point is called principal focus, where it is diverging in the mirror. The reflected rays come from a point on the principal axis. So the principal axis, principal focus is also represented by F. See here. So from principal focus in a convex mirror, it is looking like it is diverging. The rays are reflecting back and it is diverging. Here in concave mirror, all the reflected rays are meeting at a point called principal focus. All the rays of the reflected rays coming from the point, focus point, and here in case of convex mirror. So the distance between the pole and the principal focus of a spherical mirror is called focal length, and it is also represented by F. So next we will discuss about aperture. What is aperture? The diameter of the reflecting surface. So the diameter means from M to N, both in the case of convex and concave and convex mirrors. In this case, the diameter of the spherical mirror is nothing but from M to N is nothing but aperture. So spherical mirrors whose aperture is much smaller than its radius. We are considering the spherical mirrors whose aperture is very small than its radius. So from this we get a relationship between radius of the curvature and spherical mirror. What is that? Radius of the curvature is equal to twice the focal length. So R is equal to 2F. From this we will understand this principal focus of a spherical mirror lies midway between pole and center of curvature. So principal focus will be in the midway between the pole and the center of curvature in both the cases.